Alright, so here is my video on systems of linear equations, and this is for my students at the international school. Basically, I'm just making this video for kids that, they go home and they say, okay, Mr. Hop, I understood everything in class, but then I got home and forgot how to do it. So you guys can watch these videos. They're not very long. They're real quick. I just go over it very briefly, and you can help you to study for quizzes, etc. So we're doing systems of linear equations, and we already know what a linear equation is. If it's the equation, if I graph it, it comes out to be a line. When x changes, y changes by the set amount. Okay, so a system is basically where I would have two lines on a single graph. All right, so here's one line. I'll make the other line yellow. Just here we go, YOLO. All right, so I have a yellow line and a red line. So basically, the point of a system of linear equations is to find out where these lines cross. So, for example, their intersection is here. Just use this green circle to point it out. These two lines intersect at this point. All right. The special thing about this point, the thing that makes it, that makes it stand out from all the other points, is that the x and y values of this point are the same for both equations. What does that mean? Okay, so if you remember from earlier when we talked all about lines, like let's say we had a line y equals 2x plus 2. Well, there's a set of x and y values that make sense for this equation, all right? So if x equals 0, then y equals 2. If x equals 1, then y equals 4. I mean, it's very simple, right? And you guys can probably fill out an entire table of values. All right, so these are pairs. These are, pairs of variables that make the line make sense. If x is 0, y must be 2. Y cannot be 3, y cannot be 15.75, y cannot be a billion. It's just y equals 2 if x equals 0, that's it. Right, so the system of linear equations, the idea is that this point here, this green marked point, whatever x value and whatever y value this happens to be, it could be anything, then that x and y value, if I put them into both equations, then I'll get it to be true for both equations. All right, so it'll make both equations work. Now, not every system of linear equations has a solution. Not all of them do. Most of them do, but not all of them. So let me redraw the graph here, my axis of doom. Okay, I have one line that goes this way, my green line, and I'll just make another line go like, we'll make that blue, and then another line go like this, okay? So, oops, undo. Okay, there we go. Alright, so, these lines are parallel. They basically are next to each other and they will never touch. In which case, this system of linear equations has no solution. What that means is there is no point ever where these two lines will ever get back together, or however that song goes. These two lines have no solution, alright? So if they're parallel, if they have the same slope, but different y-intercepts, y-intercept is at these points right here. I'm going to circle them for you. Y-intercept number 1, y-intercept number 2. When x is 0, what is y? Alright, these are where they cross the y-axis. Alright, these points are where these two lines cross the y-axis, and they have the same slope. So parallel lines have the same slope but different y-intercepts. So this system has no solution, and that is a legitimate answer. Alright, but for everything else, things have a solution. So let's look at our problem here. I have 2x minus 3y equals negative 2, and 4x plus y equals 24. Alright, I want to figure out what is the x and y value of the point where these two lines cross each other. There's three ways to figure it out. We've gone over two of them in class. The first way is graphing. The second way is substitution. And the last is elimination. Alright? So graphing is actually pretty self-explanatory. You would just graph both of these equations like so, and then just figure out at what point do they intersect, and you just kind of use your eyeballs for that. In this case, when x equals 5 and y equals 4, then, which is this point right around here, then that is where the two intersect. Not anywhere else. Now, graphing is great and it's easy, unless of course you're dealing with equations that don't have whole numbers as their as the intersection. So if the line met at 4.3 and x equals 4.3 and y equals 5.72, you can't really use I mean, unless you have a graph that really zoomed in to like the hundredths, you would not know exactly where by looking at it. So we have an algebra to help us out, to actually give us solid numbers as to where these two happen to intersect. So we're going to use the substitution method today. Substitution method works like this. This x and this x must be the same number. Where the two lines intersect, where this line intersect, the x's are the same. So this x and this x are the same number. And this y are the same number. So since they're the same number, whenever I see a y here, I could just as well put a y here. So what I want to do is I want to try to use that fact to help me rewrite one of these equations with a single variable. Right? I don't want these two variables. If I have two variables, I can change one to help the other. So for example, this bottom one. If I make x1, for example, then 4 times 1 plus y equals 24. Okay, that's easy. Y equals 20. Well, alright, but then what happens when x is equal to 2? Well, then I get a different answer. 4 times 2 is 8, and then 8 plus 16 is 24. So it's, I can change y to fit whatever x I give it. So I don't want that. I want a single x where these two lines meet. So what I'm going to do is I'm going to try to substitute this y into this y. Alright, if I can get this y in terms of x, then I can substitute. So the first thing we're going to do is I'm going to rewrite the bottom equation in terms of y. What do I mean by in terms of? In terms of means I want to get y by itself on one side of the equation. So y equals negative 4x, I subtracted 4x from both sides, plus 24. Let's go minus 4x on both sides of the equation. So it's pretty simple. Alright, so now I've got my equation in terms of y. Well, how does it help me, Mr. Hop? It helps you because you can take this y and substitute it here, because they're the same number. This y and this y are exactly the same. So I can take this whole thing right here, this whole enchilada, negative 4x plus 24, and substitute it. And it will look something like this. So I'm going to take the top equation and rewrite it. 2x minus 3, and instead of putting this y in there, I'm going to put negative 4x plus 24, because it's the same thing as y. That's what y is equal to. The whole thing is equal to negative 2. Now, everything you do from here on out is just basic calculation that you already know how to do. The first thing we do is use distributive property. Okay, remember, don't forget to put those negatives and positives in the right place. Negative 3 times negative 4x is positive 12x. Negative 3 times 24 is, let's see, 48, 68, 72. Negative 72. Why negative and a positive? The only reason that kids get these problems wrong is they made an arithmetic mistake, or they messed up with the negatives and positives. Negative 5 minus negative 3. 5 plus negative 3, those sorts of things was where kids make mistakes, and it's because it's definitely not the logic of the problem. Alright, so I have the next step is to combine like terms. 2x plus 12x are both like terms, so let's put them together to make 14x. Minus 72, where's the 7? Equals negative 2. Alright, I want to get the x by itself, so I'm going to add 72 to both sides. 14x is equal to, alright, 72 plus negative 2 is 70. Divide by 14 on both sides, you get x is equal to 5. Okay. Well, also, we know that wherever these two lines meet, the x value is 5. Well, how do we find out the y value? Well, if x is 5, then we can figure out what y is. Alright, we can just put x, substitute it back in to this equation. Right there. And it will tell us what y is. And we'll just do the quick calculation here, but I'll do it in green, kind of separate things out a bit. Alright, so we'll just do that over here. Okay, so let's rewrite this as x equals 5. Negative 4 times 5 plus 24. Y is equal to negative 4 times 5 is negative 20. Plus 24, which of course is just 4. So I know that these two lines, y equals 2x plus 2x minus 3 equals negative 2, and 4x plus y equals 24. I know that these two lines will meet at the point 5, 4. Alright? And that's how we use substitution to help us find out the solution to a system of linear equations. And next time we'll go over elimination.